Hello, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem number 109, convert sorted list to binary search tree. So let's see the problem statement. We are given with a head of a singly linked list and where the elements are sorted in ascending order. We have to convert it to a height balanced binary search tree. So let's see an example that -10 -3 0 5 9, and we have to convert it to the corresponding binary search tree. So this is the corresponding binary search tree with the height level, as the difference between the depth from a node for its left and right subtree is not more than 1. So let's see with the diagram how we can approach this. So we are given with a linked list here starting from -10 to 9. So we have to one thing that we have to note it down here is the middle element of the linked list will be the root node of the tree at each level. So for this, for finding the middle element of the linked list, we will go with the slow and fast approach. I have already shown in my one of the video finding the middle element of the linked list, how we can find the middle element using slow fast approach. So we'll point our head pointer to the first element of the linked list, that is -10, and when we perform slow fast approach, we'll have slow pointer pointing to 0th element, 0 node, list node, and fast pointer pointing to the 9th element 9, and we will have another one previous pointer that will point just before the slow pointer. Now the slow means that's the middle element of the linked list, and as we know, and what we will use is that the middle element will go as a root node of the tree. So here the slow is the root node that we will create a new node, that will be the root node, and for the left subtree and the right subtree we will take the remaining elements on the left as a left subtree, and on the elements on the right as a right subtree. Now how to take the left list is from head to previous, and the right part will be slow dot next. So slow dot next will point to this. So this slow dot next will be 5 to 9. So as we can see, we have again 10 -3 and 5 9 here. One more important point that we have to, as soon as we divide the linked list making 0 as a root node, we have to break this link from the previous and the slow, between the previous and the slow, so that there is no infinite loop. So every time we are dividing the link between previous and the slow has to be broken. So how we can do is by doing previous dot next as equal to null. Now we have created our root node now, and we have our sublist that will go as a left and right subtree. Again, for the left subtree we have to find the root node that will be the middle element of the broken sublist. So again we will apply the slow fast approach here. We will find that -3 is the root node for this subtree, for the left subtree. Now we will make another node and we will choose -10 as the left subtree with this root node, left node for this root node, and null as the right child of this node -3. So now we have reached our base condition, because if the head dot next equal to null, then we'll return this node, and if the head is equal to null, then we return the null itself. So the left part is done. For the right part, again we have to find the root node for the right subtree and the corresponding left and right childs. So as we know that for between 5 we perform our middle finding the middle node using slow fast approach. So head is pointing to 5, previous will also point to 5, and slow and fast point to 9. So what we have to do is we have to take the element pointed by slow pointer as our root node for this subtree, and the elements on the left of this node will be the elements on the left side of this list node, and on the right side we don't have anything that is null, so we'll keep that as a null for the right child of this node, and 5 as a left child for this node, because the same 5 is on the left side of the list. So now we have reached our base condition here also. If this is head is null, we'll return null. If it is 5, then we'll return the node, because it cannot be, it's a single node, we cannot break it down into left or child nodes. So that's it, our tree is completed. So as we have already created our 0, we have -3 as our, let me change the pen. So this is our 3 here, -10 as a left child, we will make it left child, and we don't have anything on the right of -3, so that is null. On the right side of 0, that is right subtree, we have 9 and 5. So as we backtrack, will be as we backtrack from right to left from here, we will have our tree ready from the linked list log n. So the total complexity will be n log n. So let's see the code. Here we have our base condition, that head equal to null, return null, and head dot next equal to null, then return the tree with tree node with a value as the head dot val. This is the way to calculate the middle element for each recursive call, for each and this middle element, that is slow dot val, will be our root node for that subtree, and that root and to find the left child and right child, we'll again do a recursive call, and finally we'll return our root if we meet our base condition. So yeah, so let's run this. Yeah, so test cases are passing, so it means the code is fine. So I hope you like this video. Please share and subscribe. It will keep me motivated to present more such videos. Until then, bye, take care.